Welcome to Kitchen Chemistry, a series where we do a few experiments in my home and you can copy them along in your home. Mostly in the kitchen, obviously, that's why it's called Kitchen Chemistry. This is aimed at people of all ages, and so there is a mixture of different difficulty levels and different understanding levels of chemistry. But never mind about that, let's do some chemistry. If you need to know about safety, which you do, read the instructions in the text below. As usual for this series, jumping straight in, we'll talk about the parts list. So we need milk, preferably from a mammal, preferably low fat because it will squeeze the oil out, so a high fat milk is not so good. Human milk is quite high fat. Some vinegar, I've got my high strength vinegar, cheap and clear is good, but it doesn't matter. Salt, some little pan to heat it up in, a container to filter it into, kitchen roll as a filter, an oven to heat it up afterwards, and something to heat it up on. So I'm going to pour about 200 milliliters, I think, maybe 100 milliliters. No, it's more like 2. The first step, I need my small pan. I think I've gone out of shot to do this, but never mind. I need a small pan. I'm going to heat it up to about 60 degrees. I am lucky to have the thermometer that I used in another video. But if you don't have a thermometer, 60 degrees is when it gets kind of hot to touch. 50, which is the temperature that you could just about keep your finger in it, is fine, that's enough. What we're trying to do here is break the milk a little bit. So I'm going to pour the milk into this pan and heat it up. I think it gets a little bit out of control this time. We will see in a moment. But I'll fast forward over the bit where it heats up slowly and I wander around the kitchen. So I start to run around, making myself some coffee and getting the thermometer. But what I'm going to do usefully here is add some salt. 1 good teaspoon of salt to my 200 milliliters of milk. Give it a stir, let it heat up, and it's going to get to about 60 degrees. I think I overshot it slightly. It's a bit difficult to tell because my thermometer doesn't show up on this camera, but it was heading for 60 degrees and probably going to go past by a degree or 2, and so I tipped it out quickly before it got too hot. What we're doing there is damaging the milk slightly so that it can do the next step, which is add the vinegar. I'm trying to avoid putting any solid salt in there, just to have the particles of milk in there and no extra salt. So any salt, whoops, I seem to have spilled it. Try not to spill it too much. Any salt that doesn't dissolve should stay in the pan. So give everything a wipe, and then I'm going to add some vinegar. I'm going to add 1 teaspoonful to start with. Oh, we might be able to see this. No, glare. So you're going to have to trust me that it was about 60 degrees. It's hot to the touch and not really painful, which is about what 60 degrees should be. The actual temperature is not spectacularly critical, but you can see that it's already made a mess on my thermometer. It's left sort of a skin on the thermometer, which is a good sign that the milk is slightly damaged. We don't know whether we have overheated it yet. I'm going to add a teaspoonful of vinegar. We're going to add quite a lot more later, but we're going to add it in stages. First of all, I tipped it on the surface. That is interesting to look at, but not particularly useful. And then after a minute or 2, I mixed it in, and we will see that in a little bit. I found it best to add a teaspoon of vinegar every now and then for over a long time. So a teaspoon of vinegar, wait quarter of an hour, another teaspoon of vinegar, wait another quarter of an hour. And what you'll see is during the process, so this is part way through, it will start to make cheesy stuff, and that is exactly what we want. That's the protein that we want out of the milk. I did it a little bit too quickly, but if you do it, you should take your time over this and try to get it to go a little bit clear before you start, so a little straw color, and then that is much better for the filtering stage that we have next. Yours should be clearer than this. I'm hoping to put in a picture up here, but I started too soon. I'm going to start to filter it. There's a lot left over, so I added some vinegar afterwards. However, off we go, filtering with a kitchen towel in a cup It's not the best way to filter. Here is me folding a filter paper. So you fold it in half again, and open it up with just one leaf on one side and pour it into this crack. If you sort of balance it right or fold it again like this way diagonally, it will sit there very nicely, mostly, and you can put in your milk solids. Obviously you don't drink any of this because it's really vinegary by this point and pretty gross. One of the problems is that it wicks up the paper and drips all over the table, so be prepared to clean that up. You can see the chunks in here, but as I say, yours should look better, clearer and nicer. Well, nastier probably. This takes a very long time, so we're going to speed up again. So this is at high speed. It's seriously 10 times real speed. I'm making a little bit of salty solution to wash it with, but it turned out not to be necessary. I just washed it with normal water. So we want to run all of our stuff through a filter and then wash it with a bit of water to get the vinegar out. It's not very successful, but it does work to reduce the amount of smell when we get to the next stage of heating it up to get rid of the vinegar and water, because that's kind of stinky if it's really vinegary. This is taking a really long time, mostly because the filters, although they're made out of kitchen paper, which isn't a very good filter, they still block up very quickly and then very little liquid comes through. So I have to keep replacing them. I end up using a lot of bits of kitchen paper, which is lucky. I can then use them to mop the surfaces with. And gradually you can see the liquid's getting clearer and clearer because I keep adding vinegar. You won't have to do that because you will have added the correct amount the first time instead of the wrong way like I did it. Even at 20 times the speed, this seems to be going very slowly. Obviously at times it almost stopped. So you probably should keep an eye on that and make sure that you change filter paper before it blocks completely. Otherwise you'll be there a really long time, like I was. There's another whole video of this, which I will cut out because I don't think we need to watch it do that again. It just takes a very long time for the liquid to go through. After all that time, I finally got to the case where I had this relatively clear liquid that you saw earlier and this cheesy mass that it doesn't focus very well, but we'll see it again in a moment. You can see it's quite wet, so I'm going to dig it out of my filter papers. I think I ended up with several just to make it go through quicker. I'm going to dig it out, put it between layers of kitchen paper and give it a squeeze to try to get rid of a bit more water before we get to the next stage. This is, you can see it's quite fiddly because the paper is very soft at this point and I don't want to get any paper in there. This kitchen paper seems to work quite well, but you may have difficulty with it. So here at high speed, me spreading it out, squeezing it, wrapping it in paper, leaning on it a little bit on the bench, a kitchen bench in this case, and probably doing the whole thing again. Now I end up with this sort of mass. It looks like curd cheese, and it really is very similar. Oh, it's a bit squirted out that time. And now I'm going to put it into a mold. You don't need to put it into a mold, you can make it into a shape, but be aware that this does shrink a lot. So I'm going to squeeze it into this mold. It's the same mold that I used last time. I actually did both at the same time, but here I am putting the cheese polymer, the milk polymer, into this hole, and I'm going to then add a little bit of colouring to the other part of my milk polymer, or another part, and I will put it in the fourth space in my mould. As before, the mould is coated with oil and it was heated up a little bit so that the polymer doesn't stick too much. If you put it straight onto aluminium, it does stick very strongly indeed. It's possible to do it on a baking tray or on baking paper, or in a silicone mold of any kind, or just to roll it up. But be aware that if it does manage to contact some metal, it will likely stick to it. So getting to the other one, I'm just going to add in this little glass a little bit of powdered colouring and give it a mix around, and then squeeze it into the other hole. It's a little bit soft, the polymer, at this point, and not very easy to mould, but you can see it holds its shape reasonably, so we could mould something out of it. And you can also see that it's getting very coloured. So now what I'm going to do is poke it into the last hole and then put it in the oven for 2 hours at 100 degrees. That turned out to be a little bit warm, and so the next time I did it, I turned the temperature right down to 50 degrees, and that didn't damage it as much. We will see the results in a moment. So the first ones, these two, went a light brown colour because it was probably too warm and damaged the polymer, but at a lower temperature it's fine. Let's have a look at the results of that. The first one that you saw me put in, I heated up too much to about 110, 120 degrees on my oven, and they went brown. So this one was coloured red, but it is pretty much the same colour as this other one that wasn't. But they've gone very hard, and they haven't really burned, they've just gone sort of discoloured. They shrank a lot. The problem with this is that when the water boils, it generates little bubbles inside, so you have to be a bit careful. It also takes a very long time, and it kind of smells. They're not fully dry even now, but they're quite hard. And heating it up only to 50 degrees made these, which are, oops, that one nearly broke, but you can hear it the way it hits. It's very hard, even harder than the potato version. It seems to be even drier, but it has also shrunk a lot more. So this is the size of the coin, and this is the size that it ended up, about half the size of the original. I also dyed it again to make sure that that would work, and this has come out very nicely. It's come out a pinky colour. It seems to have coloured better than the potato, not potato, than the starch, which we had the time before. This is the milk protein, where it seems to have spread very well. I made several of these. They're all the same. And yes, I had the same problem all the time. It shrank, it stuck, and yeah, and it takes a very long time, and it smells of vinegar. So be aware of that when you do it. It does kind of smell if you do it inside. Obviously, if you can heat it up outside, or you live in a warm place and you can leave it for a long time, that might be nicer. But if you want to do it in a reasonable amount of time, you have to heat it up. And the only thing that normal people have is an oven for heating things up to a low temperature and drying them. So as usual, let's have a look at what's really going on. In our milk, the protein that we're interested in, which is called casein, is a polymer, but it's wrapped in a ball, and it's negatively charged, so each little molecule of casein pushes away the next molecule of casein because they're both negatively charged, and so they just repel, even though they're in water and there's other things in there. If we heat it up, it causes the protein to be slightly damaged, denatured, and it will open up a little bit, but it's still negatively charged and it still pushes other molecules of casein away. That's what I'm trying to draw in too, so I'm trying to draw it a little bit more open. If we add acid to it, we're adding H+ to it, and that will react a little bit, so it will stick on to the protein and make it less negatively charged. The reason for adding the acid slowly, and also for adding the salt, is because we want to reach a point where there is no charge on our protein so that it can all stick together. It is best to add the acid really slowly so that we can get to the point where it's got no charge instead of going past it and making it positive. And also, if we make it fall out slowly, we tend to end up with bigger pieces than if we do it quickly. So in a previous version that didn't work very well, I tipped in the acid all in one go, and I ended up with tiny particles that blocked the filter and wouldn't stick together. Then we need to crush it together to get rid of as much water as possible, and then I put it into my mold, or you could mold it into a shape. It's a little bit liquidy, so it's quite difficult to do that. At that point it goes into the oven and dries, and it shrinks because the surface tension of the water as it evaporates crushes the weak molecules and turns it into a smaller thing. What we're actually aiming for is to go back to exactly the same state that we had with our starch polymer, which was the thing last time, where the chains of the polymer are very close to each other and bonded to each other instead of something else. Our starting point here was dissolved in water, whereas the starting point for the starch was a solid that was difficult to deal with.